Welcome to another Rocket Media software technology video broadcast. This episode presents Podman Container and Minimal API modules. This video is organized as follows. First, we'll spin up a MySql database container in Podman. Then, using Visual Studio 2022, we'll code up a minimal API to access the database container. In this first module, using Podman, we'll pull down a MariaDB image and run it as a container. Then, using HeidiSql, we'll add a table to our database. Let's get this party started by launching Podman Desktop. The following sequence shows getting the image and starting the container. Now, we'll launch HeidiSql, add a table named Employees to the database, and populate it with one row of data. There, now we have a database running in a container. There's 9 fields in the Employees table. One record has been created. Now, let's get our minimal API started. Click on Program.cs in the Solution Explorer to see what comes with the empty ASP.NET Core template. The first line of minimal hosting code is the Web Application Builder piece. The second line is the Web Application piece used to configure HTTP pipelines. The next line shows a GET request mapping a root route to a Lambda expression delegate. The body of the expression is the Hello World string. Click the play button to confirm our minimal API builds and runs. Control-C to stop the Kestrel server. This next sequence shows adding a data model, adding NuGet packages, configuring the connection string, using Dapper as an object relational mapper, and adding a GET endpoint to access our MySql database. There, we now have an employee class in the models folder with 9 properties typed and named to match our database table. This sequence continues with adding the NuGet packages that our API will use. There, we now have package references to NuGet packages we installed. This sequence continues with configuring our database connection string in the appsettings.json file. There, we now have a default connection key paired with the connection string for a value. Now we'll go back to the program.cs file to start our Dapper service. This sequence continues with registering the Dapper service dependency with a singleton lifetime, then creating the service. There, now we have a Dapper service class that handles our connection string configuration. Let's go back to the program.cs file and finish up our API with a GetRequest endpoint. There, now we have a GetRequest mapping the /employees route to the Dapper service lambda expression delegate. Next, we'll add a getEmployees method to the Dapper service class. There. No more red squigglies. Let's test fly this thing. When I add the /employees route to the localhost URL, it throws an exception. It appears a little troubleshooting is required. Seems to me the employees table in the DB database started with an uppercase E. Let's see what our MySql query in the Dapper service class looks like. Aha! There it is. With our employee route added to the local host's root URL, the API request posts the standard get HTTP method, as delegated to the Dapper service getEmployees method, which gets the data from the MySql database. The API's return from the post can be seen here as a JSON formatted string of our database contents. Well, there you have it. Part 2 of this minimal API series will present representational state transfer, or REST design, and data transfer object, or DTO pattern topics.